Hello, welcome back to my channel. I'm starting a new series on Simscape Multibody inside of MATLAB. We'll begin the series with the building blocks of any mechanical system, which are the solid elements. So here's the outline for this particular topic. We'll have 5 videos to cover this topic so that it is easier for the viewers to review them. Throughout the series, I'll be trying to explain as trivial things as possible so that it appeals even to the beginners of this tool. Later, we'll move on to other areas like modeling and simulating a variety of systems inside of Simscape. For now, let's head on to MATLAB. On the command prompt, hit smnew. This will open up the Simscape multibody model template inside of Simulink. You'll see different blocks, some connected with green lines, which are called connections. Unlike in Simulink, these connections do not represent signals, but physical links with actual physical significance. This block here is the solver configuration block. Whatever solver settings you specify here will be used to solve the simulations for mechanisms linked to this connection here. The world frame is the global reference frame, which is inertial and motionless. You can consider this as the ground for all the frames ahead of this connection. Using this block, the mechanism configuration block, you can define mechanical and simulation parameters through a mechanism. The parameters include gravity. You can either specify the system to have no gravity, constant gravity, or time varying gravity. You can also specify the linearization delta for computing numerical partial derivatives using this block. However, we must note that all these settings apply only to these connections here and not elsewhere. The S to PS block changes the Simulink signal to a physical signal for Simscape, and the PS to S does the opposite of that. The scope block, just like in Simulink, displays signals generated during simulations. The rigid transform block is used to apply rotational or translational transformation between two frames. We'll review this in depth on later videos. For now, let's click on this block, solids. You can specify different geometric and physical properties for solids using this window. Note that we're defining the solid as a rigid body. Therefore, no deformation properties will be specified here. The body will only have a geometry and an inertia. Different methods are provided to define the geometry of the solid inside your system. First, there are a few common shapes already provided. For these shapes, we can just input the dimensions of the different variables that define the geometries. For instance, you can generate a cuboid by providing the dimension vector with length, width, and height either directly here or by referring to a variable in the MATLAB workspace which contains the vector with the required dimensions. Let's say we want a cuboid 10 meters long, 14 meters wide, and 20 meters tall. Hit F5 or press this button here to update the visualization window. Let's fit the solid model to view and switch to isometric view. So which is the model is already in isometric view for this case. As I said earlier, the same thing can be done in a different, much efficient way. Instead of typing the values here, let's create a variable called cuboid in the MATLAB workspace as a vector 18, 20, and let's say 40. Now we can simply link the dimensions with this variable in the solid window. Just type the name of the variable and hit F5, and now your geometry will update accordingly. This is better because now that we've linked the variable, geometry changes automatically with change in the variable cuboid, right? In the similar way, we can define the parameters for other shapes like cylinders, spheres, ellipsoids. Cylinders, spheres, bricks, and ellipsoids. However, for complex geometries which require dedicated CAD programs to model, we can import those geometries from external files. Click on From File and then browse to the location of the step or STL file of the solid that you're trying to import. Okay, so after you've imported, you can update by pressing F5 and the geometry will be displayed on the window. Yeah, that's it for this video.